And now we're going to take a look at a simple example of computer forensics or digital forensics using Python. And what we're going to do is we're going to take a look at two files and see if those files are actually the same file or not. And in order to look at that, we're going to create the files first. And the files are just going to be text files, nothing special. It's just going to be slightly tricky because we want to pretend like we're disguising the files, right? So we'll have a new file and an old file, and the old file is just going to say no one will find this, and the idea is that some cyber criminal, or just really anybody, but somebody has hidden some stuff in this file, and then they scrambled it, or they obfuscated it, they compressed it, encrypted it, and they've basically changed the file so that if we just compare it one to one, we're not going to find the file to be similar, but we are going to use some coding. And so that's why even if they did something like this, they changed the position of the text in the file, and now you'll see that they're not identical, but it still has this little bit of information here that we care about, right? So we're setting up our experiment. So then, of course, before we can compare the files, we need to be able to load them, and that's what we'll do here. We will start by saying file1, and we're going to say open, and we're going to say old file.txt, and we're going to open it for reading. We don't need to write to this one. And then file2, we're going to open new file.txt, and we can just do something as simple as print the two files, right? And let's see what that looks like. So there we go. So you see it's not giving us the text by itself. So what if we do something a little more tricky, right? So let's go back to here, and we say if file1 equals file2, we can do print success. We see there was no success because the two are not equal, right? So we're going to get a little more sophisticated. What we're going to do is we're going to fingerprint the files. And so we're going to have some hashing. And we're going to take a hash of the first file and a hash of the second file. And we're going to compare the two hashes and see if fingerprinting the two contents shows us that there's equal content in both. And so for that, we're going to use a library, and it's called hashlib, and it's a Python hashing library, and we're going to use it to create hash1 out of file1, and we're going to say hashlib, we want to use the MD5 method, and we're going to create a MD5 hash, and since it's not a big file, we can just do this hex digest, essentially a hexadecimal representation of the hash. And we're going to have a second one, and here we go. So there we go. Now the thing is, because we're using these MD5 methods, we need to encode the contents of what we're sending in UTF-8. So let's add that to both the places. And there we go. Okay, we need to actually add this read method here because we just have the file handle. So let's see. Okay, So now the way this reads is open the file, read the contents, encode it in UTF-8, and then pass it to file 1. Same thing for the new file, except pass it to file 2. So there we go, we're creating 2 hashes now. And then what we can do is we can see if hash 2 and hash 1 are equal. And then we can say duplicate file found. And if not, and here's the else syntax for Python, we can say the files do not match. And of course it says the files do not match, and you know why that is, right? If not, here I'll show you. So those are the 2 hashes. So let's take a look at them. So you see it's completely different hashes, and that's because without changing anything about the contents, you see that they have different characters in them, right? Because here we have new line, new line, new line, then dash dash, and here we just have the new line afterwards. And all we care about is this content. So knowing what we know about the contents and the kind of noise that we can find in there, the kind of obfuscation we can find in there, we can add some more stuff here. We can add a strip method to take out all the white space and the new lines, and we'll add it to both of them. And then we run it again, and you'll see it's still not a match, because even though we're getting rid of the white space, and you can see that here. Let's print the contents. So see, it's still got those dashes, right? So what can we do? So then let's add another strip method, and it's just going to get rid of those dashes. And here we'll just make this a little more spacious so it's easier to see. So we're essentially doing the same thing for both. And there we go. So that's looking a lot better. And then we just want to make sure that there's no white space after we remove the dashes. So we're going to add another strip. Look at that. We found our content. And you might say, well, that's a lot of steps. We added a lot of strip here and strip there. But that's the idea, is what we're building here is a forensic algorithm, a algorithm to dig through the noise and find the content. And that's what we did. Now we can find what we're looking for, even if somebody has taken some steps to hide it from us. And that's a simple example of forensics using Python.